second example, we have here, solve 2x minus 7 all over x minus 5 less than or equals to 3. So, let's have the solution. First step, we need to normalize, get the standard form of this rational inequality. So, how can we do that? So, let's just make this part of your inequality 0. So, we have 2x minus 7 all over x minus 5, then less than or equals to 3. So, to make this 0, we need to subtract 3 to the both side of your inequality. So, now we have 2x minus 7 all over x minus 5 minus 3 less than or equals to 3 minus 3, we have 0. Now get the LCD to simplify this rational inequality. So we have 2x minus 7 over x minus 5. So we have to cross multiply it to 3 over 1. So we have here 3 times x minus 5 all over x minus 5. So this term or your negative 3 is also equals to negative 3 because x minus 5 divided by x minus 5 is also equals to 1. So less than or equals to 0. So let us simplify. We have 2x minus 7 minus 3 times x, we have 3x. Then negative 3 times negative 5, we have positive 15. All over, since we have the same denominator, and in subtraction, we're just copying the similar denominator. So we have x minus 5 less than or equals to 0. So the simplified rational inequality, we have negative x because 2x minus 3x is equals to negative x. And then negative 7 plus 15, we have positive 8. Or 15 minus 7, that is 8. All over x minus 5. So we have negative less than or equals to 0. So for the second step, we just need to get the factors of our rational inequality. So our factor now here are negative x plus 8 and x minus 5. For the third step, we need to determine the critical points. So we have two factors. Again, we have negative x plus 8 and x minus 5. So in getting critical points, you're just equating it to 0. So negative x plus 8 equals to 0. So we have negative x, transpose here positive 8 to the right side, we have negative 8. So negative x, let's divide it both sides to negative 1 to normalize our x. We have x is equals to positive 8. Another critical points, we have to use x minus 5 equals to 0. So transpose your negative 5 to the right side, we have x equals to positive 5. So the critical numbers are positive 8 and positive 5. For the fourth step, we have testing the intervals. So what are those intervals? So from the step 3, we have negative infinity to positive 5, positive 5 to positive 8, and then last we have positive 8 to positive infinity. So what is the next step in this? What is the next column in this table? So we have the testing point. So first interval, we can consider a testing point So, testing point which is in between that interval. So, we can consider negative 10. So, now, for the third column, we need to evaluate the factors. So, what are those factors? For the numerator, we have negative x plus 8. For the denominator, we have x minus 5. Now, evaluating the factors, we just need to substitute our test point. So, we have negative 10 plus 8. So, we have negative 10. So, we have positive 10 plus 8. That is positive 18. So, this numerator is positive. So, again, we just need to consider the sign of the evaluated factor. So, next, we have negative 10 minus 5. For the denominator, we have negative 15. So, this time, this is negative. Getting the sign of the quotient, we just need to divide both signs of your numerator and denominator. So, we have positive divided by negative. So, we have a quotient which is negative. For the next interval, we have 5 to 8. Positive 5, positive 8. So, we can use 6 as your test point because it is in between 5 to 8. So, we have to evaluate our numerator. We have negative 6 plus 8. So, we have equals to positive 2. So, this is positive. For the denominator, we have 6 minus 5. That is equals to positive 1. So, this is positive. So, getting the sign of the quotient, we have positive divided by positive. That is positive. Next, last interval, we have 8 to positive infinity. So, we can use 10. So, substituting 10 to our factors, we have negative 10 plus 8. So, this is negative 2. So, negative. For the denominator, we have positive 10 rather. Minus 5, we have positive 5. So, this is positive. So, negative divided by positive, that is negative. After testing the intervals, consider only the intervals that will satisfy the rational inequality. So, in this example, the answer, always the answer will depend on the inequality symbol. So, we have here negative or less than or equal, which means the sign of the coefficient that we will consider is negative. So, from the step 4, we have the intervals. We have our the intervals that satisfy the rational inequality are negative infinity, positive 5, and 8, positive infinity. For the last step, we need to determine if these critical points are included in our solution set. So we have, first, we have x is equals to 5. So, let us substitute this to our rational inequality. So, we have 2 times 5 minus 7 all over 5 minus 5 less than or equals to 2. So, 2 times 5, that is 10 over minus 7 all over 0. So, we have 10 minus 7, 3 over 0. 3 over 0 is undefined. Meaning that x is equals to 5 is not part of our solution. For x is equals to 8, which is this critical point, let us substitute to our inequality. So we have 2x minus 7 over x minus 5 less than or equal to 3. So we have 2 times 8 minus 7, we have all over 8 minus 5 less than or equal to 3. So 2 times 8, that is 16, minus 7, that is 9. Over 8 minus 5, that is 3, less than or equal to 3. So 9 divided 3, that is 3, which is less than or equal to 3. So this inequality is correct. So meaning, positive 8 or your critical points, which is 8, is part of your solution. Therefore, the solution set is negative infinity, positive 5, union 8, positive infinity. Again, this parenthesis symbol indicates that your critical points, which is 5, is not included in your solution set. Is in your solution, but 8, which is included, so we have here bracket symbol. That's it for rational inequality.